Okay, plan for today. I would like to just go over that state diagram which I showed you last time to begin with, to show you how runtime assertion checking is going to work in Eiffel. And then for the rest of the class, I'm going to give you some quick crash course on Eiffel Syntax, which I really hope will help you complete lab number 1. But I would suggest, I suppose most of you have already started lab 1. If I talk about any particular syntax which you think is related to what you are struggling with, if you got any further question, just interrupt me, and then I will just go ahead and explain more. And I may not be able to go over all the slides about Eiffel Syntax, but I'll pick the important ones, but I'm rather self-contained. I'll make them available. You can definitely refer to them for your lab 1. I'll pick the important, the tricky ones. Okay, that's about the plan today. Let's see how far we can go. Let's go back to where we were. Let me just start with this slide here. So now we talk about Eiffel. Given that we learned about how things can be done in Java, let's now see how things can be done nicely in Eiffel. So decide by contract is really supported natively in Eiffel because they got specific keywords for precondition, postcondition invariants. Let me just show you very quickly an idea. And again, that's a survival guide for Eiffel. Okay, so this class over here, which I also made the source code available to you, this part here is really version 5 of your Java code for the bank application. Okay, and this is basically how you would do it in Eiffel. I would say it's nice and clean. Let me just point to you the important stuff, and then you will do that just for almost every lab and projects. First of all, we have a class called account and create make. I'll explain this a little bit later. But basically, it is trying to declare to say, I want to use this particular feature or method as the constructor. If you don't put any creates in the beginning, that means there's no constructor for this particular class. That's something different from Java. And then we declare attributes. By the way, you can see that every time you have a feature clause over here, that means we're starting a new section. If you have gone through the tutorial video, this will show quite nicely as an outline view in Eiffel Studio. Okay, different feature section. We got 2 attributes here, owner and balance, and then we got this particular make over here. If you only look at the make by itself, it's basically like a mutator in Java, just something that will change the attribute values. But over there, in line number 3, we actually declare this particular mutator to be a constructor. Okay, that's kind of a Eiffel-specific concept. Okay, and then for every feature, we have require for precondition, and also we have ensure for postcondition. Things will get a little bit more interesting when we talk about inheritance. For a subclass, how is it going to inherit the contracts from its parents? Okay, that's something we're going to talk about a little bit later. Okay, just as a preview. You can think about it too. And then within the do and end, that's kind of the implementation. A very common source of error is, you should keep in mind, for all the contracts, there are only 3 places you can put the contracts, either require for precondition, ensure for postcondition, invariant for class invariants. These 3 places, you must put a Boolean expression. Okay. On the other hand, for the do body over here, you must put some instructions, which means you want to do some updates. Okay. That's something I will go over with you. I do have some slides to show you the common errors. Okay, that's about the supplier side for the account. And then what's really important about having pre and post condition is, sometimes, remember we said, actually always, the client is not interested whatsoever about the implementation. So in Eiffel Studio, you can show the contract view of your class. That's basically what lab number 1 is requiring you to do. When you are done with your matrix class, I'm not so interested in your implementation in your diagram, the bond diagram. You want to show me only the contract view, which means for me as a client of your matrix class, how should be the behavior look like for each feature? You only show the pre, post conditions, and class invariants. But for the implementation, I'll run other tests to test your code. It's different concerns. They are orthogonal. Okay? Okay, that's about the contract view. Basically, the difference between this slide and the previous slides is over here, we don't have the do body. That's it. That's the only difference, which means we don't show any supplier-specific implementation. We're simply not interested. Okay? Okay, anatomy of a class, basically that's something I already said. For each class, you can declare, you have to explicitly list the mutators or commands that you want to use as constructors. I'll cover more details when I get there in the slides. And then we have, usually, well, it's not really required, but I'll recommend. You can have one feature section for attributes. You can have one feature section for commands or mutators, okay? And also you can have one feature for queries or accessors, right? I'm just trying to get you used to the terms. And you can have one invariance, right? Nice and clean, the section here, okay? Okay, so that's good. Okay, nothing to be said. Oh, by the way, over here for the invariance, if you simply just write an invariant keyword here without writing anything below, it's also fine. That simply means you have no invariance. So a very extreme case is, let's say you do have require and ensure for every feature, and you do have an invariance, but you simply leave them empty. It's as if you put true for the precondition, postcondition, class invariance. Is that good? Well, you're basically programming Eiffel as if you were programming Java, right? There's no contract there. Okay, so that's something to note. Of course, sometimes maybe you really don't want to have any precondition or postcondition. Sometimes, but I would say for most of the time, you do want to think about what kind of contracts you want to put. That's why we are using Eiffel to teach you design. Okay, it's a general guidance. Okay, after that, anatomy of feature. So I'm going to, for the rest of the course, whenever I talk about command, I meant mutator. When I talk about query, I meant accessor. Okay, just different terms. Okay. So now here's a general structure for a command. You can have require, and you can have local. Now, some of you actually I saw on Wednesday's lab, you kind of swap the order between local and require. It's considered as a syntax error. There's a reasoning behind this. Let me explain to you. The reason that we are putting require before local is as follows. Think about require is like the obligation for the clients, right? The clients must satisfy the precondition before you can execute the implementation for the supplier. Is local part of the implementation? It is, because you declare local variable in order for you to manipulate. So that means you must make sure the client's obligation is satisfied before you go on to see the implementation. That's why local should come after the require. That's the reason. That's a language choice, language design choice. If you're more interested about language design choice, you can take the, I think maybe at the 4th year we have some language design course. Okay, require local, and then we got do for the implementation. So local and do, they actually constitute the implementation. We have ensure for the postcondition. Okay, so you can read it through. And if you simply leave require part to be empty, it's as if you put true. Okay, that's pretty much like what I gave to you as starter code, right, for the lab number 1. Okay, and also for, okay, that's just for command. Okay, that'll be it for the anatomy. Any questions so far? Yes?
How does create know whether we're designating something as a constructor or creating a new object? Because there's 2 uses for create.
Okay, how about this? Let me get back to this when I cover the create. Let me just save your question when I talk about it. Otherwise, you'll be a little bit sidetracked. Okay, I'll definitely answer that, but when I talk about the syntax for Eiffel, one slide will be about create. Maybe ask me that question. That'd be more relevant. Okay. Okay. Now let's. I would like to just go back to this diagram here, and then let me switch to my iPad. Okay. Again, let me remind you very quickly, so in case we have forgotten. Okay. Now I want you to pay attention to several things over here. We have 2 attributes over here. Remember, when we talk about the states of a particular kind of objects, the states simply means how can you characterize an object. The way you characterize it is by having the attribute value for the objects. For example, when I say Jim, combination of Jim and 20, so this is one state for the object, right? This is just specific value. What can be conceptually, what would be all the states for an account objects? You will basically be all the combinations of string and integer conceptually, right? Just cross products between the 2 types. Okay. But whenever I talk about states, I really talk about some combination of the attribute values. Some are valid, some are invalid. For example, if the balance happens to be -1, that's definitely invalid. Okay. Okay, we have make over here, which has a precondition saying that the balance must be larger than or equal to 0, let's say. And we also have withdraw command, which has a precondition, has 2 preconditions to say the amount must be non-negative, and also amount cannot be too big. Okay? And also we got ensure clause over here to say the balance must be equal to O balance minus amount. Okay? So these are, and also we got invariant over here. So now we do have precondition and postcondition for both features, and also we got invariance for the class. Now the question is, how does Eiffel check these contracts at the runtime? You must understand this, otherwise it's difficult for you to understand how your program behaves. So I started to draw some state diagram already. I will continue from there. Let's just see what we have gone so far from Monday, Tuesday. Okay, so what we got, let me just review very quickly. We say that as soon as we try to create an object by calling the constructor using the keyword create, whenever you see create in Eiffel, you can think about it's like a new keyword in Java. We are trying to create a new object by calling the constructor. As soon as we try to call the constructor, we cannot call its body implementation right away. We have to make sure the precondition is satisfied. If it is not satisfied, then it's going to be some precondition violation, right? It's a different branch, okay? Which is completely possible. And then as soon as we realize the precondition for the constructor is satisfied, then we'll execute the body of the constructor to create the objects. And now, after we have done what the supplier has implemented, so now here comes to check if the supplier has fulfilled their obligations, which means we're going to check the postcondition. In this case, this is the postcondition for the make, which means the amount, the balance and the owner has been set for this particular account objects. Okay? If the postcondition is satisfied, then we can go to certain states of the objects. Okay? If it is not satisfied, then of course we have another kind of contract violation, which is called postcondition violation. Okay? Now, this yellow, this state over here, which are highlighted as yellow, it is not a very stable state. Because let's say, for example, if I try to initialize the balance to be -10, which means I'll set the balance to be not -10. Even if the postcondition is satisfied, it doesn't guarantee the invariant is satisfied. That means we got to check the invariant as well. That is why we got one more check to do to see if the balance is larger than 0. So that means the postcondition is satisfied and also the invariant is satisfied. So that's why now we get this green state over here. So this is the safe states for us to do anything further. Okay? Otherwise, we might have the invariant violation. Any question about this? Even though I'm talking about the contract checking for constructor, the way you check for any other kind of feature is completely the same. So I'll just do it anyway, just as a review. Okay? Just make sure you can really extrapolate that for all your features, okay, for later projects. Let's do it together. Let's say I want to do the following. Let's say I want to call withdraw from this safe state here. If I say I want to call something like account dot withdraw certain amount, just A. Okay? And then as soon as I initiate a call, what should we do? Checking the precondition. Very good. Okay, let's check it. And remember, the precondition for that is simply the new balance must be larger than or equal to 0. Basically, that's what we will do. So in the case where it is satisfied, then we'll simply say, if A is larger than 0, what does that mean? Oh yeah, of course. Yeah, if the precondition is satisfied, then what should be the next step? Execute the body of the code, right? Okay, very good. So now let me just write it down, and then we can talk about the other case. You're going to execute account dot withdraw A. If it is not satisfied, that means we have also precondition violation. That means if it is not the case that A is larger than 0. It's only part of the precondition, right? Of course. Oh, by the way, you can see that over here. When you look at the withdraw precondition over here, you can see we have, let me just explain this first. You can see there are two parts separated by colon, right? That means the first part, okay, you can see there's a colon over here. And then the first part, let me say the first part is just the Boolean condition here. That's a Boolean, right, for the contracts. The second part is something called a tag. And the tag is a very useful mechanism for you to somehow trace to see which, because sometimes you may not just have a very big conjunction of conditions. You want to decompose them into different concerns, right? For example, you can see for the matrix, you want to make sure, for example, the row must be valid and also the column must be valid. So there are different concerns. So now you can think in this way. When you actually have two separate preconditions, it's as if, let me call this 1, and this is 2. It's as if you say 1 conjoined with 2. Basically, new line is like a conjunction. Okay, I'm saying that in order for me to execute the body of the withdrawal, the first condition must be satisfied. You'll be checked first. If it is satisfied, go ahead and check the second one. If the second one is satisfied, go ahead and execute the body of the code. What if the first one is violated? Well, precondition violation, right? If the first one satisfied, but the second, if the first one is satisfied, but the second one is violated, you also get precondition violation, right? It goes sequentially, right?
What about instead of and? What if you want or?
Okay, so no, it's not possible. If you really want, it's a good question. The question was, what if I want to have an or behavior for some reason rather than and? Okay, here's the thing. If you separated two preconditions or postconditions by a new line, it definitely means conjunction. There's no way to change it. If you really meant to say disjunction or, the only way you can put it is to say, let me put it here. I would say alternative. Okay? You gotta say 1 or 2 by yourself as to make it a single precondition. That's the only way to do it. Okay? Questions? Yes.
Does it only show up when it's violated?
Yes, good question. So what's the usefulness of these tags? There are two usefulness. There are two purposes. First of all, let's say when there is certain contract violation occur at the runtime, you will see in the Eiffel Studio, it will tell you which precondition is violated. If there's no tag, it will simply show you this condition over here, which sometimes can be confusing. So you better give some very meaningful tag for traceability. Okay? So the main purpose is for traceability. So you can trace back to the contract to see which one has been violated. Okay? And the second purpose, which I will talk about on Tuesday, when you do testing, you want to test to see if your contract is working the way you expect. And in that case, I can say, now, I want to, let's say, I want to pass an amount that's negative. And I want to make sure the precondition with the tag non-negative amount is really violated, but not others. I want to make sure exactly the exact expected contract is violated. That's something I will cover in more detail on Tuesday. So in case you don't get it, that's okay. Okay, let me just close it. Sorry about that. Okay, what if I just allow? Got to enter a password, right? I don't think you can see my password, but let's see. Okay, forgot about my password. Last resort. Get rid of it. You know what? Hopefully it wouldn't bother us anymore. Sorry about that. Okay, any question about this? Go ahead. Yeah. Very good question. The question was, can you use local variables in the pre or post conditions? Okay, the answer is no to both. Let's think logically. It's not arbitrary, it's logical. Pre and post conditions are somehow to be seen by the clients. Do clients care about the implementation of their supplier? They don't. Is local part of the implementation? It is. So they shouldn't appear in the pre or post condition. So it wouldn't be allowed. So you can try, if you try to mention any local variable like a loop counter in your pre or post condition, it's going to complain to say I is not visible at this level here. Yes?
If I don't make the constructor, it makes a default constructor.
Mm-hmm.
Right? Does it do the same in?
So okay, the question is about default constructor. Let me get to this point maybe a little bit later. It's a little bit sidetracked, but the answer is yes. We do have some default constructor in Eiffel. I mean,
not like in Java.
Mm-hmm. So okay, so you might have seen something called default creates in the entry class for your lab 1. So that is something like the default constructor in Eiffel. Let me explain a bit more detail later. Yeah, okay, but we do have it. Yes, we do have it. Okay, let's go back there. And remember, there are two post conditions to check, and the second one to check will be amount less than balance. So what I would do is, I will just conceptually, you can think about the precondition is going to be a larger than 0 and a less than or equal to balance. Okay, let me just make sure, less than. less than balance. Okay, and over here, I'll just say if it is not the case that A larger than 0 and A less than balance, then it's going to be precondition violation. Okay, we execute the body of the code of the implementation, and then we're going to reach certain states over here. So that means the supplier has somehow has terminated the execution of the implementation. Next step, post-condition check. Very good. Okay. So now there are two cases over here. Let me mention the violation one. If the post-condition is violated, then we definitely go to post-condition violation. Otherwise, we should go to this kind of unstable states. Unstable because we haven't checked the invariant yet. Okay, but we'll do that in just a moment. So after that, we're gonna draw the diagram like this, like that. And the post-condition is gonna be balance is equal to O balance minus amount, right? I just would save my time, so you can I'll just say post-condition over here. Okay, and then this is not the case that post-condition is satisfied. Okay, once we reach this particular unstable states, you can see as the diagram is now complete because it tells us once you get to this yellow unstable states, you must always check to see the resulting states from this particular feature call, does it satisfy the invariance? Does it maintain the integrity of the objects? In this case, if it is, then you go to green states. Once you go back to the green state, what does that mean? That means the object can receive just another feature call, maybe deposit or other things. Okay, that's kind of the lifetime for the object in the context of decide-by contracts. Okay, you got precondition, post-condition, invariant check. Okay, any question about this? Okay, of course, if you want to see a nicer diagram, it's here. Okay, I already posted, so you can look at that because that one is going to help you a lot when you think about the runtime behavior and if you want to debug your program. And also, you will see another diagram over here which looks almost the same. So this one here, I'll let you read it. Basically, I just made the case completely general. For any of your class, basically, the diagram structure is the same. Over here, I simply say, let me use a different color here. A.make, the make over here is just any of the constructors your class declares. So you may have multiple constructors. So for any one of them, if you try to call, it is subject to the same check. And similarly, this is the feature that you have in your class, which can be anything, right? Depending on which class you're having, right? So this diagram is completely general. Okay, that's about what I want to say if you have no question about runtime assertion checking. Okay, good. Okay, so let me go back to the slides and then we can go over them. Okay, so basically this is exactly what I said before. So now there's something I want to just remind you very quickly, and then we'll talk about this in detail next week. So if you can think about the way post-condition works, pretty much like how we did it manually in Java, because the post-condition can refer to the old and new values of the same attributes. So that means under the hood, there's got to be some kind of a caching mechanism, which means before the feature is executed, Eiffel runtime has to store the old values of the relevant attributes so they can compare them after those attributes are modified. Okay, that's all you have to know for now. I'm going to address this in more detail when we talk about how you can write complete contracts, which you have to do in Lab 1. Yes?
What happens if the object dies?
What do you mean the object dies?
Like if you're doing like C++, like C, when you like kill an object, you have to free up all the memories.
Okay, good. Good question. Okay, basically, yeah.
No reference, and then there's obviously
Yeah, Eiffel is like a Java that they do automatic garbage collection. So you have no ability to actually free the memory yourself, right? So it's just like all the OOP. So actually, the idea about OOP is they want to raise your level of abstraction from doing any alloc or the allocation of the memory. So you cannot do that.
So when the garbage collects, do they check for like all these conditions or something?
No, the garbage collection works the same way. They only check to see if there's any pointers under the hood pointing to this particular objects. If there's no pointer pointing to there, they're simply going to collect it when there's no use. But there's something done automatically, you don't have to worry. So that's actually at a lower level, which we don't have to worry for this course. You just have to pay attention to how the contracts are checked at the runtime. Okay, that's about this slide. You can read it over. Everything we have said, nothing you have missing. Okay. Okay, so let me just say one more thing to finish this slide, and then for the rest of the class, I'm going to talk about syntax. Okay. Hopefully that will help. Okay, now I just want to say I would like you to try the sample code for Eiffel to really make sure you can reproduce all the contract violation. For example, I'll just show you one. Let's say over here, I'm trying to create an account over here. Okay, I got Alan of type account, and then create Alan with negative balance over here. Apparently, this is going to violate over here, as we said, the precondition over here, right? And the precondition has a tag called positive balance, right? That's exactly what you will see. Let me just show you a snapshot, but I will encourage you to reproduce that yourself. If you go there, you will see that, sorry, it's a little bit small, but you can see that it's like a runtime violation in Eiffel Studio. So it tells you this particular positive balance precondition is violated, and then over here, it shows you that. So that's what the traceability I talked about before. Depending on which one you fail, it will show you the corresponding tag, if any. So it is recommended as a good style if you associate each postcondition or invariant with a tag. That's exactly what I did for your lab 1. Try to follow that style. It's beneficial. Okay, and for the rest of the slides, you can just go through different kind of contract violation, and hopefully that will make more sense to you. Any questions before I move on to syntax? Okay, good. Let's now talk about syntax. Okay. Okay, this one's done. Let me just exit from there. We'll start from the very basics, and then we'll get more and more complicated syntax as we go. Okay. Okay, let's see over here. Just bear with me. The Adobe Reader is being very slow. Okay, there we go. Okay, it shows. Okay, there we go. Let's start. Does it show? If I can. Syntax, okay, there we go, that's the right one. Okay, let's just full screen mode. There we go. Let's start. And let's make sure iPad is still live. Good. Okay, now, I'm not going to talk about every slide in detail, but only the important ones, since we got quite many. Okay. First slide, escape sequence, very easy. You can read it through yourself. Basically, you're going to use percentage sign rather than slash. That's it. Escape sequences. And now, this is just about terminology. In Java, we talk about attributes, mutators, we talk about accessors. But for now, for the rest of the course, I'm going to talk about still attributes, but everything is a feature. Feature is the most general term in Eiffel. You just say feature. And then you can say attributes still, but for mutators, I might just say commands. And for accessors, I'll say queries. Okay? Just try to get used to it. About the naming convention, for cluster names, cluster name is like a package in Java, the same naming convention. Okay, all lower cases separated by underscore. And also for the class name, it's going to be all capitals separated by underscore. And then for feature name, rather than, well, you can see that the difference here, right? So the feature name, like attributes, command, and queries, is going to be all lower cases separated by underscore. Okay.
So in general, what do you put, like, how do you distinguish what you put under model and root? And what do you put in root?
Root is more like the main controller. So basically, you want to put application class where it's going to call everything in the model. Model simply means it's the main business logic, right? We'll talk more about model, especially for your projects and lab number 3. That's something we'll talk later. Okay, now here is the number one thing I want to talk about between Eiffel and Java. Okay, before I show you the slides, let's go to Eiffel. Let's go to iPad. Okay, we know in Java, when you say A equals B versus A equals B, you know that very well, right? The first one means assignments. The second one means a Boolean expression to compare the two values, right? We know that very well. First of all, syntactically speaking, in Eiffel, let me just put it side by side. In Eiffel, this is the syntax they have. For here, when you say A equals B, that means A equals B in Java. If you want to do assignments, you got to do A is assigned to B, colon equal. The reason for them to decide on in this syntax over here is, before you learn about Java, when you see A single equal B, would you rather think the Eiffel way or the Java way? Before you learn about your first programming language. Eiffel way, that's why. It's math, exactly. That's exactly math. And they choose, they want to reserve single equal for mathematical equality, so they have to make up something for assignment. That's why they put colon equal. Okay, it's a language choice. I wouldn't say good or bad, just a language choice. Okay, but I'm just trying to explain to you. But if you like math, this might be more straightforward to you, right? Okay, so here comes the thing. You should never ever try to use this kind of notation over here in the contracts. Never ever. Because this is simply an assignment. An assignment is like an instruction. It does not return any Boolean value. So you cannot use it in the contracts. Okay? You should never ever use it. You'll get a compile time error. Okay, that's about the slides. Okay, exactly what I just said. Okay. You can read it through. Attribute declarations. And again, let me just say that very quickly. In Java, if you say something like, if I say person, let me just use consistent colors. If you say person P, what you would say in Eiffel is P is of type person. Of course, it should be all capitals. And again, there's a language choice. There's a reason for that. Again, mathematical. This colon over here corresponds to the symbol like this. What's that? It's an element of. So the way they think of it is like person tells you the set of all possible runtime objects of type person, and P is just one of them. That's what it means. Okay? Should I write it down for you, maybe? Okay. So person over here, the set of all possible runtime objects of type person. Okay? And P is just a member of them. Yes?
How does it not get confused with the tag?
With a tag? Oh, okay. So the question was, why is the computer not confused with the colon over here, which means is a member of versus a tag for precondition? Okay. The answer is, any one of you took 2001 already? Okay, you know about context-free grammar, right? Context-free grammar means you have to somehow, okay, how about we do a little bit of context-free grammar? Just conceptually, sketch. I like this question. It wasn't asked last fall. I like that. Think about, let's say we do have a rule called feature. It's going to be, okay, let me say feature followed by, okay, of course you have a rule for name, followed by precondition, which is a rule, and followed by, let's say, local variable. So these are all rules. So the non-terminals, right? If you have no clue what I'm talking about, that's fine. I'm just trying to address that very quickly. Okay? So now for the precondition over here, Basically, it's going to be a name, colon as a token, and followed by some Boolean expression, which is just another complicated rule. Okay? And then precondition cannot be empty. So that means, depending on the context you are seeing this, right? For the local variable over here, it's just going to be a list of name, followed by, in this case, it's just going to be another name, not Boolean expression. So the grammar for this are simply not ambiguous. Okay? So it's okay. It's going to be fine. Nobody's going to get confused. Okay, is it okay? Okay. In case you don't really like this part over here, I can undo it. Just to keep that safe, clean. Okay, just like here. Okay, that's about attribute declaration. Okay, what about method or feature declaration? Very quickly. For the command, you can see that it's actually the same idea. For the command, it's like a mutator, which means it does not return anything. Okay, deposit in this case doesn't return anything. You don't put void, by the way. There's no void. When you talk about void in Eiffel, it means something different. Void is like a null in Eiffel. Okay, but I'll talk about void safety next time. Okay, command, that's a structure. And now, you can see the colon again over here, right? Okay, the same reasoning. So over here, we say that whenever you call sum of whatever value it is, it should be a member of integer. That's what it means. So rather than putting integer in front of sum of, like in Java, in Eiffel, you put whatever the query name it is, followed by the parameter list. You say whatever it is, the return value is going to be a member of that type. Okay? Again, that's it's more like a mathematical notation. Okay. And also one thing to note, you can see when you have more than one parameters, you should separate them by semicolon, whereas in Java it's like a comma. Okay. Again, some subtlety you have to notice. Okay. Okay, logical operators. Okay. Now let me say something over here. Basically, how do you express logic in Java? Well, the best you can, let's say for conjunction, the best you can do will be ampersand, right? Let me talk about a little bit Java to test your knowledge, okay? Let me ask you this. Let's say A is an array. I is an integer for now, okay? In Java, if I write the following, AI larger than or equal to 0 and 0 less than or equal to I, and I less than a dot length, versus 0 less than or equal to I, and I less than a dot length, and AI larger than or equal to 0. In Java, do they mean the same thing? If you claim that they're conjunction, one of the rules for conjunction is commutativity, right? P and Q should be equivalent to Q and P. If you think the ampersand in Java is really conjunction, then these two must be completely equivalent. Are they? Can anybody explain to me? Nothing about Eiffel here, just about Java.
If the first condition fails, the compiler will check for the next condition.
Yeah, you're not compiler, the runtime. Okay, basically that's exactly correct. Let me just say that first, and then let me review that very quickly. Okay, so it's something called short circuit. So short circuit means the runtime is going to evaluate the 3 different parts from left to right. Remember for conjunction, okay, let me just review that very quickly. Okay, and the case for disjunction is completely symmetric. Okay, we know that for conjunction over here, if I got P and Q over here, true, 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 false, false, true, false, false. We know that the only case you can get green is when both are true, right? If any one of them is actually false, you will just get false, right? So this is logic. At the runtime monitor for Java is trying to be a little bit smart over here. Because logically speaking, if we know that if this is already false, overall, the conjunction would be false anyway, so you shouldn't bother to evaluate the rest of the conditions here. Okay, good. So that's short circuit. So now, yeah, go ahead.
You still have to explain this because you might answer my question.
Say that again. Yeah, just say your question. Maybe that's something I'm going to say.
You were talking about how if these are exactly the same, even considering short circuiting.
They are not the same. Maybe that's exactly what we're going to talk about. Okay, so they're not the same. Okay, logically speaking, they should be equivalent if you think conjunction is the same as && in Java. The answer is no, okay? Because think about this. Okay, let me explain to you. You can tell me why they are not equivalent. At the runtime, we're going to evaluate from left to right for the 3 conditions. As soon as we hit the very first condition that evaluates to false, we're going to stop right there. Okay? Given that, do you think, let me number them over here. 1 and 2. Which one is completely safe at the runtime? Based on what I just said. From left to right, as soon as you hit the false, you stop. Based on these 2 principles. 1 or 2? Second one, okay, so that means you meant the first one is not safe. How? Give me one example where you can fail. Yeah? Null pointer exception, okay, yes. If A happens to be, well, you know what, how about this? Let's assume A is not null, because since I didn't put a condition there. How about that? Give me another failing condition, yes.
Using an index on exception.
Yes, exactly. You can see that over here. For number 2 over there, we first check to see if I is too small or not. And the second, if it is not too small, if satisfy the condition, we go ahead and evaluate if it is too big. If it is true, that means it is not too big, so I is a valid index. And then we go ahead and evaluate the third condition. Okay, so they're called the guarding condition, basically. So first guarding condition, second guarding condition, only if both of them are true will we actually bother to evaluate this guy over here. Okay, good. So the conclusion is, && we are so much used to up to now, they are not exactly logical conjunction. They are not. And the symmetric argument applies to disjunction for the vertical bar. Now, back to Eiffel. That's why Eiffel actually got 2 groups of connectors for you. Okay, it's very easy to see. Now that you see the difference over here. First of all, what's the Eiffel correspondence to &&? And then. What about Eiffel's, okay, and then I would say, what about logical conjunction? In Java, there's no such a thing. But for Eiffel, and without a then. Okay, I'm gonna give you an example, but I just want to tell you the syntax rule. For Eiffel, the complete logical operator will be and, or, implies, and the equal sign that we talk about, right, is for equality. It's basically like an if and only if. Okay, so whatever you want to do in math, like what you learn in 1019, you definitely can do that in Eiffel. Okay, now let's go back to short circuit. How can short circuit be useful? Okay, let's do one example here. Let's say I have, for example, something like this. Let's say I want to have let's say I'll just say any command. Any command, okay? And then I'm passing an array of integer, for example, and semicolon, don't forget. And then we got some I here, which is an index integer. Let's see something very interesting over here. Now I want to have a require. Basically, I is going to be used as an index for this array. I want to make sure it's valid, right? So now, in the precondition, there are 2 ways you can write it. Okay? Let me show you. Well, remember I said before, precondition is going to be checked sequentially, right, from top to bottom. Okay? So version number 1, this is what you can write. Version number 1, you can say, for example, not too small. You can simply say I is larger than or equal to 0. Okay? The next one, not too big. And then you can say I is less than, for example, a dot count, for example. Assuming that if the array you have is actually start with indices 0. Okay? And also, you also got something like, let's say positive. And you can say AI is larger than 0. Okay, you can see I got 3 tags and 3 3 tags and 3 Boolean conditions here. And this is safe because by the time we evaluate the precondition with positive tag, we are pretty sure I is valid. But now let me ask you this. Hypothetically, if I swap the order of, let's say I put these two after this, it might fail, right? Because if I happens to be too small, let's say if I happens to be -1, in that case, I will be checking this precondition first, and then a minus 1 is going to give me index out of bound exception. Well, pretty much like that, right? Invalid index. So that means if you use this style, make sure you arrange the precondition in a way that makes sense. Okay, so the green version there doesn't work. Okay, hopefully you know the reason. So version 2 doesn't work. Okay, that's about the first way to write it. What about the second way? So the second way, pretty much like how we did in Java. I'll just show it to you. So the second way to write it would be something like this. You can say, let's say, I'll simply say this. Positive elements. I'll show you the working version first. Okay, we have colon here. Colon. And then I would say something like this. I larger than or equal to 0. And then I less than a dot count. I'll say a dot c. And then ai larger than 0. So this will work. Okay, you can see the correspondence, right? Now, hypothetically, if I try to do the following, hypothetically, let me use a different color here. If I simply say this part over here, I'm going to move it before that, and then say, basically I'm going to say I less than a dot count, and then, oh, sorry, what am I doing? Okay, let me do it again. If I try to do the following over here, I'm gonna actually swap this one and put it after that. Okay, that means I'm gonna do AI larger than 0, and then I larger than equal to 0, and then I less than a dot count. Is it gonna fail? Well, it might, right? If I is invalid for exactly the same reason for number 1, exactly the same reason. So the short circuit in Eiffel works just the same way. I'm just trying to show you that they do have some equivalence to logical operator with no short circuit evaluation. So when should you use which? I would say it's always safe if you use the short circuit version. But I would say when you put it in the precondition, postcondition, if you don't think you need to have this kind of guarding conditions, you can just use logical. I wouldn't force you to use either one. I'm just trying to tell you the difference. But again, this is really a language choice, a language design choice for Eiffel. It does want to separate between with short circuit and without a short circuit. Okay, questions?
So you said the third way, it doesn't have short circuit?
The third way, which one? You mean this one here? Which one? This one? In the orange one. The orange one still have short circuit because you still use and then, right? I'm just swapping the order.
What's the difference between version 1 and the last version?
You mean version 1? Oh, version 1 and the last one, they are the same. Oh, it's a very good question.
It's just like different way of...
Okay, how about this? The question was, what's the difference between, okay, let me just try to highlight this, okay? So now, what's the difference, the version 1. Version 1 is gonna check this one first. If it violates, we got precondition violation already. Otherwise, we're going to check this one, and then we check this one. That's the order. Okay? And the red version, not the orange one, the original one I put, is the equivalent to that. We're going to check this first. If it is true, we go ahead and check the second one. If it is also true, we go ahead and check the third one. So these are equivalent. One is from top to down, the other one is from left to right.
Oh, I thought you were trying to show like one has short circuit, one doesn't have short circuit.
You may want to maybe just re-watch that part. That's not what I meant to say. But if you still got questions, yeah, go ahead.
Does array index in Eiffel starts at 1?
So the complete story is in Eiffel, you can start the array indices by any value. You can start that with 0. You can start that with 1. You can start that with any value you like. But I would say by default, it starts with 1, by default. However, there is a feature in the array library called rebase, which will allow you to rebase that to 0-based. But for your lab number 1, look at that instruction. I try to force you in a way so it wouldn't cause any confusion. Okay? Yeah, but just try to get used to it, right? Yeah. Yes.
So like for the first one, it shows you the different paths. It like gives you different paths.
Yeah,
But the
true.
second one only show you one path.
Yeah, true. So for the very first one, the version 1 over there, for the version 1 there, the advantage is if this guy failed, it's going to show you which condition you failed, right, with a tag. On the other hand, the second one, even though the order of checking the condition is the same, but if this one failed, it will still show you this. If the if the first one failed, it show you this. If the second one failed, it also show you this. Okay, that's well, they are same or also different at the same time. Yes. Yeah.
What happens if you use and not and then?
Sorry, say that again.
What happens for the orange one if you use and not and then?
Okay, for the orange one. Okay, guys. Okay, please. Okay, the question is, let me put it down. Otherwise, you'll get confused. So I larger than or equal to 0 and I less than a.count and ai larger than 0. First of all, if you use and rather than then, that means you're not really expecting any short circuit. So now that depends on how at the runtime Eiffel is going to evaluate the conditions. But I would say typically they will still do from left to right, typically. Okay? Depends on how they optimize the underlying code. But I shouldn't rely on that too much. Actually, you shouldn't do that. Rely on that for any language, right? Okay, because it's logical, right? For logically speaking, if you got P and Q and R, doesn't matter which one you evaluate first, right? Logically speaking. Any other questions, please? Okay. Rebase. Rebase. Yes, outcome. Yeah, I'll just write it down. Yes, questions somewhere.
So the intact conclusion is like it's very similar to Java's then.
You mean the and then or?
Like the comparison, the ampersand comparison, the logical conjunction. It's like similar to Java.
Yeah, similar. I'm just trying to say in Eiffel, if you do want to just emphasize, I'm using just logical operator, right? I can just use and as opposed to and then. But and then has a direct correspondence to ampersand, ampersand. That's my point. Yeah.
So Eiffel has its own language.
Eiffel is a language.
No, but for the name or though, I mean, for the operator or.
Yeah, it has its own syntax. Yeah.
Right.
Yep. Well, every language, every programming language has its own syntax, right? Every language. Okay, good. Let's go on. Okay, I'll let you go through. Okay, a very quick review. Okay. Oh, now for this part, review of proposition logic. I wouldn't bother you for that. Include the slides. I would say I include just the minimum that you have to know for this course. Especially for the final part of this course, we're going to give you a little bit of introduction to program verification. To say, given a piece of code, doesn't have to be Eiffel, even though we use Eiffel as an example. How can you prove the correctness of the code? And also, how can you prove that the code will actually terminate? So that's something we're going to use loop variants, and something will go in the later part of the course. So you will need this kind of logic later. Okay, I'll just include slides, so I would suggest you go over them when you have time. Okay, but you can just go over them. They are again, they're self-contained. Okay, let me go to the next topic. And these are just some example propositional axioms or theorems you should know. Okay, again, predicates. And of course, for lab number 1, or the labs onwards, you are supposed to know universal and existential quantification, which we'll learn today. I'll show you at least the syntax, how you can do it. Okay, we'll definitely go through example. Okay, let me just go to the next one. Okay. Oh, logical operator I already covered. Okay, short circuit, we just said already. So if you go through the slides, so here I'm just talking about more examples which you can go over. If you got trouble, again, speak to me during the office hour or the lab session. Okay, division and modulo. Okay, again, it's a syntax correspondence. So if you want to do integer division, to get a quotient, sorry. Yes, if you want to do integer division to get a quotient, you would say double /. Okay, if you want to do the modulo to get a remainder, double /. Okay? That's, again, just a syntax. Okay, that's how you declare a class. Okay, it's easy. And, okay, for the constructor. Okay, now I want you to look at this fragment of code over here. If you look at the feature section over there, so there are basically 2 commands over there, make and make2. So they are simply just normal mutators commands. However, in order to create an instance of bank account, you can only call make to make it. You cannot call make2. The choice is not arbitrary. It's our choice because under the create, in line number 3, we said we list all the commands that can be used in order to call the create the objects. Okay, let me show you exactly what I meant. Okay, look at that, and then I'm going to show you a new page over here. Oh, make and make2, right? Okay, over here. Okay, so now remember in the creation clause, we got make, and then under the feature clause, we have make and the rest of the detail, and also make2, the rest of the details. So what does that mean? That means, okay, let me talk about object creation as well. Let me again give you a little bit syntax review. In Java, this is what you would do. Person, P, is assigned to new person. Okay, let's say default constructor, just make it easier for you. How would you translate that into Eiffel? The translation is not exactly direct, but I'll try to approximate that for you. Okay, basically, what you got to do is you got to convert the new into creates. Okay, you're going to say something like this. Okay, can you guys do me just a favor? I just don't want to run over time. Could you make sure I got at least 20 minutes to talk about across? Do we still have 20 minutes or less than that? Okay, when I got exactly 20 minutes left, just raise your hand. Tell me you should really move on. Okay. Let's make sure. If you forgot to remind me, oh, too bad. Okay. Okay. Now, how do you do that? So new is going to be creates, and now let me test you about it. In Java, right, 2030, we talk about person here and person here. So they are called different types, right? Polymorphism is the hint. The left-hand side, the person is called static type. The right-hand side is called dynamic type. Don't worry, if you don't have any clue about this, we will review this systematically in this course. It's really important for OOP design. Okay? Anyway, so let me say this. So now over here, let me just give you one example. Assuming that we got a person class over here, and under person, let's say we got 2 classes over here. If you don't mind, let's say we have student class, and we have maybe professor class, okay? And now, if you actually say, let's say all of them are just not abstract. None of them is abstract. So this is okay, person and person, okay? Now, so this is called dynamic type at the runtime. This is called static type at in the compile time. So now, in the case where the dynamic type is the same as the static type. There are two ways for you to write it in Eiffel, two ways. Simpler way and the wordy way, okay? So now for this one, let me say when the static type is exactly equal to dynamic type, okay? Case number one. Okay, that's what you can write. You can either write creates, the dynamic type is simply person over here, and then I can say p dot make. So the make over here depends on what you declare under the creates, depends. Yes, go ahead. I got exactly 20, really? How about this, I finish this within a few minutes and I'll go directly to across. How about that? Okay, good. Okay, good, thank you. Okay, for this case, and then we got say p dot make. Okay, that's one thing. Or we can say, in this case, the dynamic type is exactly the same. We can simply say p dot make. If you write this, Eiffel knows that the dynamic type should be exactly the same as the static type. On the other hand, if I say person p is assigned to new prof, okay, in that case, you have only one way to write it. Case 2, static type not equal to dynamic type. You can only say creates, what should you write? Prof. That's the dynamic type, p dot make. Okay? Okay, I should really stop here. Okay, and I'll talk about across. That's really important. That's the key for making your lab 1 work. So I'll definitely talk about it. Okay, so for the rest of the slide, I'm going to make 2 sets of slides for you. They are completely self-contained. The first one is just for this syntax guide. Look through them, find anything useful, reuse them in your lab. And the second one is just the common mistakes that you can make on Eiffel. Look through them as well. Okay, so now let me go directly to across. You will need them very badly. Okay, let me go directly there. Okay, so now about across. Let me just make a summary for you first of all. Let's make a summary here. So when you say across something or, oh sorry, let me say it again. Something as or and. This corresponds to like a for all. Okay, you got all here. If you got something like across as sum, and this corresponds to existential quantification. Okay, these two things can be used in the contracts mainly. I would say they can also be used in the implementation because they simply just return the Boolean values. For this, look at the common errors slides. It shows you examples there. Okay. On the other hand, there's another one. We will talk about the iterator pattern later in the course, maybe later next week. Basically, iterator pattern, which you may have be briefly exposed to in 2030. So all the library collection clause, like array, linked list, array2, hash table, they are all iterable. So they are all applicable to the across syntax. Okay. But for now, I'll just say this: across as loop and. Okay, so this is simply just like a loop structure. And now one thing I want to emphasize, do not use this in the contract. Simply because this does not return anything. It's just like a while loop or for loop. It simply performs some updates without returning anything. So never ever use this in the contracts, or you get a compilation error. Okay, that's about the syntax summary. Let's see some example, and then from there we can have discussion. Yes?
What about the until?
Until, good. Let me show that very quickly. You do have a, okay, let me just see that very quickly. For, you know what? How about this? Let me save some writing. Let me just go, maybe that's in previous slides. Loops over here. Okay, let's see this very quickly. In the Java world, you can say while some condition is true, I'm gonna stay in the loop and do something, right? In the Eiffel way, they do exit condition, which means it's a logical negation of this. Instead of saying as long as the loop condition is true, I'm gonna stay. It's going to say as soon as the condition becomes true, I'm going to exit. It's logical negation, just different way of thinking. So over here, I'm saying as long as I is less than 10, I'm going to stay in the loop. How do you put it in the Eiffel way? That means as soon as I becomes larger than or equal to 10, exit. That's why in the next slides, you see something like this. Larger than or equal to 10. Just a different way of thinking. Apart from that, you can see that we also get from over here. From is simply somewhere for you to initialize some certain variables relevant to your loop. Okay? And then the loop over here, just like a body. You can think about loop end is like a curly brackets in Java for the while loop. Okay? It's a very direct correspondence. Okay? So let me just add this to here. Of course, for the loop, you can either use across loop end, or you can say from until loop end. So these are the two kinds of loops you can write. Okay? These are the two kinds. The only difference is for this kind of loop over here, there's no loop counter. As you see more example, you will see. Okay? But sometimes you may just want to get the element from the collection one by one, in which case you don't really need a loop counter. Okay? Okay, let's see more example. Okay? And then we'll discuss. Yeah, go ahead.
So we can always use the across all, but we cannot always use the across loop.
No. Across all and across some, you can use them both in the contracts and in the implementation. For the across loop and also from until, you can only use them in the implementation. And the principle is very easy. For the require, ensure, and invariance, they are expecting something that returns a Boolean. And the from until and also the across loop, they do not return anything. So they cannot be used as contracts. That's the principle. Okay? So I do encourage you to go over the common error slides, which you're going to make available today. You will see lots of story there. Okay? That's a good question. Okay? Okay, now let's see example. Okay, first of all, you can iterate through some array or linked list. Basically, for now, you don't, okay, let me just look at that. Can you please just look at these two lines of code and I'm going to explain them. I just want to put it in my iPad. I will explain the case for array, and then the case for linked list is just the same. There's only one common confusion I would like to emphasize. Okay, and then I'm almost done. Okay, let's now move here. Just I want to make some slight modification here, and then we are done. Account, okay, A, and then we're going to say, again, cursor, dot, item, dot, withdraw. 10. Okay, let's say A is an array of account, and then we're trying to walk through A, and for each individual account, we're going to withdraw $10. That's what the loop is trying to do. Let's understand the structure over here. First of all, can this block of code be used as a contract? No, it's a loop. No. Okay, first of all. And then the most common confusion is understanding what this is and why we need the item over here. Okay? Huh? To access. Okay, let me just conceptually, we're going to talk about details of this next week when we talk about iterator pattern. Conceptually thinking this way. This is the array of accounts, which is implementation. Basically, we can try to across the array over here, and the way we across it is by creating an iterator object to iterate through it. So you can think about what it does. The cursor over here, so the cursor is basically pointing to some cursor objects, the iterator objects. And the iterator objects is basically trying to access this particular array one by one. And every time, if you want to get, okay, so for example, it might point to the very first item in the array to begin with, right? And the next time, it's going to say, point to the next one. And then point to the next one. Just one by one, right? That's how the iterator works, conceptually. Now, this is why the cursor over here is not exactly, the cursor object over here. Okay, let me just make it very clear here. When you say cursor only, it's only talking about this cursor objects. But if you want to talk about the item that is being pointed to, you have to say cursor the item. That's the reason. Okay, so you're going to say cursor the item dot withdraw. If you simply say cursor dot withdraw, it's going to be compile time error. It's the most common error for this kind of loop. Please get it right. Okay, question? Of course I can. Let me do it again. First of all, when you talk about the cursor over here, you're talking about this iterator object over here. Not really the item that is being pointed to by the iterator at the moment. So that's why you have to say item over here so that it's going to tell you what the item is. That's why. Okay? It's very subtle, I know, but yeah.
Right, and in this case, the item is account.
Correct. In this case, the item is exactly account because remember, every element in the array is account. Okay? So that's why you can call the withdrawal. Okay, any other questions? Go ahead. Item, no, not a keyword, it's a feature. It's a feature in the iterator class. So cursor is of type iterator. So that's why I can say cursor the item, which goes to whatever it is pointing to at the moment. And then which is account. That's why you can call withdraw afterwards.
Cursor index is a feature of the cursor.
Say that again?
Cursor index.
Cursor index, yes. Mm-hmm. You can look it up. You can look at the API. Yeah, API. Sorry, API of the iterator class. Yes.
Don't I need add item to access each one? So, for example, like when we have in Java array at I.
Oh, it's different. You can see it over here. When you say cursor the item, you already okay. You can think about when we are using a cross over here, we are really iterating through every element in the array one by one. And the way we iterate through it is by saying we have an iterator. And then every time we just go to the one that's being pointing to. So you don't really need a square brackets notation. It's being abstracted away for you. You don't have to. It's just a different way of accessing the object.
I can use this way or I use.
You can use this way? Yeah. Mm-hmm. You know, for this, since this is implementation, it has a loop. You can feel free to use from and until loop. That's also fine. So I'll write it very quickly. I really want to get to one complicated example for a cross. Okay, let me say that very quickly. So this one here is exactly equivalent to this. From, for example, I, let's say I is a loop counter. Let's say I is assigned to a dot lower until I is larger than a dot upper. I want to loop. Every loop, I'm going to say a at position I, what you're suggesting here, and no item anymore. There's no iterator in this context. Withdraw. Am I okay with this code here? Anything I miss here? Oh yeah, upper, lower, they are simply the features in array. You can look it up. They are defined. Any problem with this code, or you think that's okay? Yes? It's not incremented counter. If you try to write this, it's going to infinite loop. Okay, you know what? It's good I mentioned this example. If you try to use from until loop end, this kind of structure here, you must explicitly increment the loop counter. On the other hand, for this one here, you don't have to. There's no loop counter. It manages for you. There's no loop counter here. It simply goes to the item one by one. But here, you're basically going from lower to upper. But you got to make sure you update that. And as a preview, later on, you will be given a fragment of code like this and prove mathematically why it doesn't terminate later on. Okay? Yes, question? Huh? Cross, yeah. Across, yes. Okay, how about we just do one more example? I do want to get to that example, otherwise you'll be struggling. Okay, this one is rather easy over here. Okay, this one here, basically we're just using cursor. You always have to say cursor the item. So now, using 20 seconds to convince yourself. Over here, when I say across collection as cursor, let's say collection is any iterable. I'll talk about iterable next week, don't worry. So let's say iterable can be array, linked list, or hash table. So now, this across all n here checks to see if every element in the array of integer is positive. Right? A very common error is you simply say cursor rather than cursor the item. Okay?
Sorry, what's the issue with that?
Oh, you should say cursor the item over here rather than just cursor.
Oh yeah.
Yeah. Yeah, exactly. Yeah. Okay. Now let's do one more example, which I really, really want you to understand. Okay. Okay. Now over here, two examples actually. I'll try to do 2 minutes each. Okay. How about that? So this one here, let's say we want to do a binary search. Remember, I said before, what's the precondition for binary search? The array has to be sorted, right? This is how you specify in math. Convince yourself that's right. Okay? This is how you do in Eiffel. Now, over here, you can also do this syntax in Eiffel. Basically, I'm creating a list of integers, like an interval, from 1. So vertical bar, dot, dot, vertical bar is a valid syntax in Eiffel. That's fine. Okay? And then you say accounts.count minus 1. And you should put a bracket around, parentheses. And then you can simply say that. Okay? Now, the most important thing for your lab 1. Now, let's say this. Question for you. I have an array of accounts. I want to make sure no 2 accounts in the array have the same ID. No duplicates. Think for a moment, how would you do that in math? Think for a moment. Once you figure this out, translating into Eiffel, I need to only measure one detail and we're done. Give it okay, make it even simpler. You give it an array of integer. How do you write for all to make sure that there's no duplicates in the contents?
Is it sorted
No,
though?
nothing about sorted. I'm just saying there's no duplicates. No duplicates. Well, if you say compare each item, no, it's not good enough. Not quite. Try.
Compare I with each and every item and then increment I and keep on doing.
Something like that. You want to compare basically every pair of indices. If the I and j you're talking about are not the same indices, that means the elements must be different. Make sense? Okay? Now, this is how it looks like in math. Look at that. No, don't be scared. It's very simple, okay? Yeah? First of all, could you please spend just 20 seconds? Look at that. Look at that. We have 2 dummy variables here, right? I and j. How does this relate to lab number 1? For each matrix, what 2 variables do you have to iterate through? Row and column, okay? Now, you got I and j. In math, it's very easy. You just use one single quantification. However, in Eiffel, after all, it's a programming language. You cannot use a single across to have 2 dummy variables, like a 2 cursor. You cannot. So what can you do instead? You have to use nested. Okay, let me just say one more thing about math. Okay, basically, the math you are seeing right now is equivalent to the following. You want to say for every I, and then for every j, right? It's equivalent. So now, how do we use across over here? Okay, let me just tell you roughly. Okay, and then we're done. Okay, let me just mention this. That's the most important thing for today. I start with across. Across, let's say A as an array. Oh, actually, let me say this. Across 1 until, let's say 10. I'll just make it 10. Okay, as cursor 1. And then I would say maybe, let's say for all, right? So these are the keywords. So that's one single dummy variable. How do I nest that? So that means the body of this all here is expecting another Boolean, don't you agree? So that means just put another across over here. So let me write it down in a different color here. So you're going to say across 10 as C2, brilliant. And then I'm going to say all here, let me finish the rest, and then we're done. N. And now we're expecting another Boolean. Of course, depending on what you need, you can nest for as many as you like. Depends. Okay, that's a structure. And now how do we do that? Let me just do that quickly for you. I can say something like this. I can say C1.item, if C1.item not equal to C2.item, right, implies the array, which is A, at C1.item is not equal to the array at C2.item. Let me make it more complete for you. Maybe you can think about this can be A.lower and this can be A.upper. And similarly, A.lower and this is A.upper. Okay, I'll take questions before we draw a closure to today. Okay, just bear with us. Okay, any questions? So .lower and .upper, they are simply the features in the array class. But in your case, you may have to put different lower bound and upper bound, right? Right? Hopefully you'll be smart enough to figure out what the lower bound and upper bound is. But I want to mainly just take questions. If there's anything you don't understand about this syntax, please say it now. Okay? Yes, go ahead.
That line down there?
Which color?
The C1 item.
C1 the item?
Yeah.
Yeah. So over here, basically, well, if you look at the math over here, it simply tells you that if basically, logically speaking, right? I would say for every I and j in between lower and upper, and then I would say if I is not equal to j, that implies ai is not equal to aj. Right? That's what we would say. Okay, guys, hopefully that helped. And if you got more questions, drop by my office hour today or next week. Okay?